In the mechanics laboratory, students carry out experimental work on the following topics: determination of the gravitational constant, verification of the law of conservation of momentum, methods for determining free-fall acceleration, motion of a projectile launched at an angle to the horizontal, centrifugal force, gyroscopic precession, Maxwell's wheel, and the speed of sound in air. In the molecular physics laboratory, students study the following experiments: dependence of gas pressure on volume at constant temperature, measurement of the temperature dependence of the coefficient of linear expansion in solids, determination of the volumetric expansion coefficient of liquids, single plate method for determining thermal conductivity, determination of the efficiency of a solar collector as a function of the heated water volume, determination of the specific heat capacity of solids, observation of the liquid-gas phase transition at the critical point, determination of the adiabatic index of air using the Richard method. In the electricity and magnetism radioelectronics laboratory, students study the following laboratory experiments: determination of resistances using the Wheatstone bridge, investigation of the temperature dependence of conductor resistance, study of the electrostatic field using an electrolytic bath, determination of capacitive reactance in an alternating current circuit, determination of the electrochemical equivalent of copper, measurement of the force acting on a current-carrying conductor in a uniform magnetic field, demonstration of alternating current decay using a voltohme meter, measurement of the Earth's magnetic field using a rotating induction coil, study of the magnetization curve and hysteresis of ferromagnetic materials, measurement of the magnetic field produced by a straight conductor and a circular loop, investigation of the voltampere characteristics of diodes, study of the voltampere characteristics of Zener diodes, investigation of the voltampere characteristics of light-emitting diodes, study of the diode characteristics of transistors, transistor-based switches, transistor amplifiers, investigation of the characteristics of bipolar junction transistors, use of transistors as functional generators, application of De Morgan's laws. In the optics laboratory, students perform the following experiments: spherical aberration in lenses, determination of the focal length of converging and diverging lenses, Newton's rings in transmitted and reflected white light, determination of the radius of curvature of a lens, determination of the refractive index and dispersion of liquids, absorption spectrum in colored liquids, diffraction of light at a secondary slit, recording and analyzing results using videocom, study of interference phenomena in a Fresnel mirror using a helium-neon laser, determination of the wavelength of the helium-neon laser radiation using a Michelson interferometer, determination of the refractive index of air using a Mach-Zehnder interferometer, study of Fresnel's law of reflection, investigation of the rotation of the plane of polarization in a sugar solution, temperature dependence of black body radiation intensity, study of radiation spectrum lines using a diffraction grating spectrometer, investigation of the properties of polarized light, polarization laws for lambda-2 and lambda-4 plates, study of the linear spectra of inert gases and metal vapors using a prism spectrometer, determination of the wavelength of light using a diffraction grating, determination of the refractive index of gases using a Rayleigh interferometer. Laboratory sessions on atomic physics. Students perform the following experiments: the Frank-Hertz experiment, determination of Planck's constant, study of the hydrogen atom spectrum, determination of the specific charge of the electron, determination of the Stefan-Boltzmann constant, measurement of the elementary electric charge using Millikan's oil drop method, investigation of the dependence of the cadmium-red spectral line splitting on the magnitude of the magnetic field using a Fabry-Perot spectrometer. In the laboratory of nuclear physics and elementary particles, students carry out the following experimental works: examination of the dependence of beta radiation intensity on distance, determination of the half-life of the barium-137M radioisotope, study of the statistical nature of nuclear processes, demonstration of particle tracks using the Wilson cloud chamber, nuclear magnetic resonance in polystyrene, glycerin, and Teflon, alpha spectroscopy of radioactive samples, detection of gamma radiation using a scintillation counter, fundamentals of dosimetry. All necessary facilities are provided in the physics laboratories for students to conduct these experiments, and the sessions are carried out in strict compliance with safety regulations.